Hello and welcome to this lecture on vector calculus. In this video, we are going to solve the problem on directional derivative. So first, find the directional derivative of the given function pi at the point 1, 1, 1 in the direction 2i cap plus 2j cap minus k cap. So first we want to know that dd. Here I represent dd as directional derivative. Here it will be on the form of gradient pi into a cap, where a cap will be a vector divided by modulus of a vector. So here they have given pi. So by using pi, we want to find gradient pi first. Then we want to go for a cap. A cap will be a vector by modulus of a vector. Here they have given the direction. This will be our a vector. So I am taking that direction as a vector. So I may take this a 2j cap 2I cap minus k cap. And how do you find this modulus? The modulus of a vector will be square root of each term with the sum. So finally we find a cap and gradient pi. Now we use to multiply both, and if it is on the scalar product I vector dot I vector will be 1. If it is on the different vectors I make it 0. So by using these rules we are going to find the directional derivative for this function pi. So first of all, we know that gradient pi will be dou pi by dou x I vector plus dou pi by dou y j vector plus dou pi by dou z k vector. Then I will find dou pi by dou x. So here it is our dou pi. So dou pi by dou x means it will be 6x. The remaining terms become 0. And I will find dou pi by dou y. So if I differentiate pi with respect to y, I will get y alone. That is 2. Dou pi by dou z. Here it will be minus 3. So then I will substitute over this. Here it will be 6x I vector plus 2j vector minus 3k vector. And they ask the gradient at the point 1, 1, 1. So here the variable is only x. So at the point 1, 1, 1, I will get 6 I vector plus 2j vector minus 3k vector. So this will be our gradient pi at the point 1, 1, 1. Therefore, this is the final value for the gradient pi. Now we want to find directional derivative means we want to find the gradient pi in the a cap. So we want to evaluate the a cap first. So on the next step, a cap can be derived by a vector by modulus of a vector. So a vector is given in the problem. Modulus of a vector means square root of the square of these terms. 2 square plus 2 square minus 1 square. So it will be of square root of 9, it will become 3. Therefore, it will be 2i vector plus 2j vector minus k vector divided by 3. This is our a cap. After finding this, to find the directional derivative, so we want to find the gradient pi into a cap. So at last we substitute over this with the multiplication, we will get the final value. Let's see. A cap, it will be 2i vector plus 2j vector minus k divided by 3. Now we want to go for the directional derivative. It will be on deep direction. It is the notation. And gradient pi into a cap. This is our a cap. Gradient pi already we find 6i plus 2j minus 3k. So by using this, if I multiply over this, here it is I. So here it will be 12. And 2. Here it will be plus 4. And 3 minus 1. Here it will be plus 3. Okay. Then finally by 3. If I add up these terms, I will get the value 19 by 3. Okay. Now we want to find the direction derivative of this function pi in this direction I cap plus 2j cap plus 2k cap at the point 1 comma minus 1 comma 3. So same we want to find the directional derivative means we want to find gradient pi and we want to go for a cap where a cap will be a vector divided by modulus of a vector. So by using this, first we will find the gradient pi. It will be dou pi by dou x I vector plus dou pi by dou y j vector plus dou pi by dou z k vector. So first of all, if I find dou pi by dou x, here it will be 2y and dou pi by dou y, it will be of 2x. And if I find dou pi by dou z, here it will be 2z. Okay, by using this, we will find all this value and we will make a substitution. At last, they have given the point 1 comma minus 1 comma 3. So we will substitute the values of yx, y, z in this formula. Now I am getting the answer as 2i vector plus 2j vector plus 6k vector. Then we want to go for the directional normal direction vector. It will be of a cap. A cap, na, it will be of a vector by modulus of a vector. This is our a vector. This is given the problem. Modulus of a vector is square root of the square of the terms with the sum. So I am just taking the terms and squaring it. Then finally I am getting as 3. So if you make that a cap, that will be a vector by 3. So we will substitute the value of a vector and then I am substituting the value of modulus of a vector. It will be 3. So therefore the direction derivative as getting the idea of gradient phi dot a cap the multiplication and then I it becomes 1, jj becomes 1 and kk becomes as 1 with the same coordinates. So here finally I am getting this as 14 by 3.